Hey guys, this is Mitch with Fine Point CGI, and today we're going to talk about how to do drop-in, drop-out multiplayer using Nakama with Godot. So this is a continuation of my previous tutorial where I talked about how to integrate Nakama into Godot. So make sure that you have at least gone through that entire tutorial series. There should be a list of tutorials that you have to go through to do this. So please go through those precursors. It basically sets up Nakama, sets up everything, teaches you everything that you ever need to know about Nakama before you jump into this tutorial. But today we're going to talk about drop-in, drop-out multiplayer. We're going to talk about how to handle connections and things like that. And we're going to debug a really weird state issue that caused quite a bit of trouble. So that's what I have in store for you guys today. So let's go ahead and get started. Okay, so the first thing we need to do is we need to talk about some of the changes between now and the previous tutorial. So if you remember in the previous Nakama tutorial, we talked about how to get our stuff up onto DigitalOcean. So inside of our client.gd, we came in here and we edited our default key, our IP address, and our HTTP to HTTPS. Make sure you rechange this to this right here if you're gonna self-host. If you're not gonna self-host, then go ahead and just leave it to whatever you guys want. And what I mean by self-host, I mean I'm running it locally on my Docker desktop so that I can run my stuff locally. Now, of course, you don't have to do this if you have your stuff set up. It's just that since I'm traveling, I don't have access to my normal setup. So I'm going to be using a localized setup. So I just want to make sure you guys are aware that those are some of the changes that I have made. And the other one, just to make sure that you are aware, is if I go into my UI scene here, I have my test@gmail.com email login and my match stuff set up. So what that means to you is panel 3 and panel 2 are currently shown and the rest are hidden. Now, of course, you can keep the rest open if you want to, but in my case, I have these guys set up this way because it's going to be easier for me to walk through the tutorial. So now, what are some changes that we need to make to actually handle drop-in, drop-out multiplayer? So let's first talk this out by kind of planning out our thoughts, okay? So how our current system operates is we have a player joins, starts, creates room, right? And then they get added to a players, right? And then from there, what happens is they head out and wait for another player. And then when another player joins, so when client 2 joins, then we head out to here. We send our data to client 1. Client 1 repeats the data to everybody, right? And then it adds the player to the player group, like so. Something like that, more or less. And basically, we wait for another player, and we also wait, and I'll put something in the middle here, like this. Does host, press start. This is basically how it works. And then when the host press start, tells all the connected players to start the game, and then we drop into our scene manager. So when we drop into our scene manager spawns players, assigns their unique ID, and then go ahead and starts the game. And so basically that's how, in general, our system works. It's relatively simple. So now we're going to need to modify this to be slightly more complicated. Instead of doing what we're doing here, where we're basically player creates room, add players to group, waits for another player, and then basically does the player press start. And if they don't, and then a client joins, then we send our data to our clients, right? We repeat that data to everybody, and then they add that to the group. This logic here is going to be the same. We're not going to change nothing here. But what we'll also do is create an event over here that basically says player connected, like that, and then player disconnected as well. And when a player connects, we're just going to add them to our player group like that, much like we do here. And on player disconnect, we're just going to remove them from the player group. And when they add the player group, we're going to have an if block in here. And we're basically going to say, is game playing? If so, we're going to spawn our new player. And if not, then we are going to just add them to the dictionary. Because we've already added them to the dictionary, we'll just end. And if the exact same thing is going on, but we are disconnecting, just bring this over here, drag this guy over here. We can remove the player, and is the game player, then remove spawned player. And that's basically how we can handle when a player connects and disconnects. And one other thing that we have to check is when we do this, add players to group, does host press start. So when that happens, normally what we do here is we tell all the connected players to start the game, and then we start the game. But we also check if all the players are ready. So instead, we're going to still check if all the players are ready. And I know that this seems like a very simple change, but it's going to change how we handle our spawn logic. It's going to change how we handle our actual scene management. And what I mean by that is we're going to have to come up with a way to do some error checking. So when a player gets spawned, we also need to broadcast all the players' information. So that would include stuff like their positions, their rotations. In this case, it's pretty much just going to be positions, but we'll need to broadcast all of that information so they have all that information. We'll also need to abstract our player position syncing stuff. So that's going to be something that we'll have to take a look at. And then from there, we could basically end. And then when we remove the spawned player, we'll basically just remove that spawned player, and then we will end. And that's pretty much how we're going to set this up. It's pretty simple on its surface, but it's going to be a lot of changes to our scene manager, to our client, and a little bit to our game manager, if I remember correctly. It'll be a lot of changes to our scene manager and to our client. So it's going to be quite a bit of changes there. And then we're going to go into our player and probably make a few adjustments there as well, because our player is going to need to synchronize its position and synchronize all of its information. So anyway, now that we have some basic plan of what we're going to do, let's jump into Godot and let's modify this stuff. So now that we're inside of Godot, we need to basically code our changes. So let's head into our script. And the first thing that we need to do is we need to make sure that our connection string is set up correctly. So you can see here, I have mine set to default key 127001 and HTTP. And I believe I said this at the beginning of the tutorial, but that's because I am running a local server here. So just be sure to set it to whatever you need it to be. But in my case, that is what I have it set to. Now, the next big thing we need to change is we need to know when somebody comes in. So if you remember, inside of set multiplayer bridge, we are connecting our match join error here. Well, we need to also handle when somebody joins a match. So before, the way we approached it was when a person joins a match, we're handling it on peer connected. Now we're going to handle it on match joined. So we'll say multiplayer bridge dot match joined dot connect, and then we'll connect that to on matched join like that. And that will pass us over to a on match join. And if you take a look, if we hit Control F, we do actually have a on match join right here. So this will be used to handle a lot of our user stuff. Now, we also need to come in and adjust our multiplayer connected. So let's head back up here to on peer connected, and let's take a look at that. So you can see here we have a if not player has ID. We also need to make sure that our own ID isn't getting pulled in. So we'll say ID does not equal multiplayer dot get unique ID and this. And that's basically just our way of making it a little bit better and a little bit more reasonable. Now we also will need to come in here and notify player of progress when they join, but we'll get to that later once we get things settled. So you'll also see here we have a on peer disconnected. Remember, if you remember our diagram, when they disconnect, we need to actually take them out of the peer list, right? So if players dot has ID, then we can rip them out of their connection. So we'll say players dot erase ID, and that will pull them. And then we'll need to come up with a way to RPC that out to everybody. So I'm going to come up with a function called player disconnected.rpc, and I'll pass in that ID. And that's a way for us to actually disconnect the player and remove them from the game. And I know that I'm kind of going through this line by line, but we'll get to that in a minute. So when a player joins a match, if you remember again from our diagram, we need to say, hey, when the player joins, I want them to be added to our match. So we'll say var unique ID is equal to multiplayer dot get unique ID. And then we'll say if not players dot has unique ID, like that. And then we can basically add them. So we'll say players bracket unique ID is equal to an object, and that object is going to have name colon unique ID comma and then ready colon 0, because they're not ready, right? They just joined the game, they're not ready yet. And then we'll go ahead and do a small print so that way we can keep track of this person being added. And there we go. And that's basically going to allow it when the player joins, they can actually register as a person. And we can get rid of that extra little bracket there. Now, let's head down to our ready code. So if you remember, we have some ready code right here where we're setting up our game and getting it ready. So this part's going to change quite a bit. So first things first, just in case, if our players does not have the ID of that person, let's go ahead and add them. So if you remember up here, which we were just there, so you guys should remember, we had a section here where we are adding a player. Let's just grab that and let's paste that. And that basically allows us just to add that player just in case. So for some reason, when the player connected or when they joined the match, it didn't somehow pick it up. That is basically what we're doing, is we're just making sure that that exists just in case. And then instead of doing this section here, if ready players is equal to player size, we also want to check if our player dot size is greater than 0 and this. And that basically just makes it so that way we can't start the game with 0 players. I know that that's kind of strange, but sometimes if a state gets weird or something like that, it's just a check against that. We want to make sure that our stuff is safe and effective, and we don't want a match that exists somewhere that's not being played. So that's kind of the purpose of that. And now let's come down here inside of this section here where start game is, and let's add in a few functions. So first things first, if you remember, we have a player disconnected. So func player disconnected, like that. We'll pass in an ID, and we'll basically come in here and say when a player disconnects, let's remove that player. So var player underscore node is equal to get tree dot get root get node or null, and let's pass in str ID. And that's basically going to search the entire tree for that node and then rip that node out. So if player node, then let's queue that free like that. And that basically means that when a player disconnects, it's going to search our entire node structure, find that player, and pull them out and delete them. And that basically allows us to delete the nodes on everybody's computer. So think of it kind of like this. So a player, and I got to go find where that is right here. So when a player disconnects, the peer gets disconnected. And when that happens, the host gets notified. So if I'm the host, I get notified. And then I tell you to go and disconnect the rest of the players. I erase them out of my ID list. And then you guys go in and delete them from your node list. And that's basically how that's approached. And this is not declared in scope, which doesn't make sense. Let me go check. There we go. I just misspelled it as per usual. And basically, we're going to RPC this. So we need to tell this to be an RPC function. So at RPC, quote, any peer, comma, quote, call local. And that'll basically force that to run on everyone's machine so everyone deletes everything. And that should work just fine. And now we need a way to notify our game progress. So let's code up a function to do that. So when a player connects, if we go up to, I believe, on peer connected right here, when we print out our players, we're saying here's all the players that are in our project here. We need to notify player of progress. So if get tree dot get nodes in group, and then we're going to come up with a new group, and that's going to be the in-game group. And I'm going to say dot size, and we're going to make that greater than 0. And we'll notify game in progress like that. And then we'll dot RPC, and we're going to RPC ID that ID. And what that's going to do is it's going to say, hey, only this one player, here is the progress of the project, if that makes sense. So this is where you would translate all of your data. So for instance, if you were to be playing a game like Core Keeper, right? Core Keeper has what this person has in their inventory. It has what this person looks like, things like that. That's what this function is going to be for. It's to pass that data across. So when we want to notify our game in progress, if I scroll down to where that is, which in my case is just above the group, but you guys can put it wherever you want, of course. We're going to come in here and say at RPC, any peer, like that. And we'll say func notify game in progress, like that. And what we'll do is we'll print out a received progress, like that. And we're going to make sure that we're in the player's dictionary. So first things first, we'll say var unique underscore ID is equal to multiplayer dot get unique ID. If not players dot has unique ID, then we can come and say players bracket unique ID is equal to quote name colon unique ID comma ready, and we'll go with 1. Now again, this is where you would pass over everything else that you need to do. So, if you have stats or things like that, this is where you would pass that over. And then if they already have that person's information, then we'll just go ahead and just say they're ready. So players bracket unique ID is equal to dot ready is equal to 1. And then we can emit our start game. So on start game dot emit that, and then we can now hide our project, our screen here. And that's basically everything that we need to do inside of our client.gd. Thankfully, it's not a whole lot, but that's pretty much what we need to do to get drop in, drop out to work, at least within the client side. So now the question is, okay, that's great. What else needs to change? Now, the big one that we have to change is our scene manager. So if you remember, we have our game manager here, which has our multiplayer scene, and we have a scene manager associated with that. This is where the majority of our changes are going to be. Okay, we're going to need to come in and sync our player position, see what happens when a player leaves middle game, right? When a player joins mid game, things like that. So the first thing we need to change inside of our scene manager is we need to come up with a way to effectively handle when a player starts a game. So you can see here, all we're doing here is we're literally just spawning people. Now, all of that is basically going to get ripped out and we're going to start over. But first things first, we'll add in a group. So we'll add to group in game like that. And then we'll come in here. We'll keep our spawn points because we want to keep those. And we'll come in here and do, let's see here. We'll do some error checking. So if you play the game currently, it just crashes. It doesn't really notify you what's wrong. But if you play the game without having any players, the game just crashes. So we need to basically handle that. So if keys.size is equal to 0, then let's go ahead and just print a warning. And basically, once we do that, we'll just add in a local player. So var local ID is equal to get tree dot get multiplayer dot get unique ID. And that'll just pull back our unique ID. And then we'll say Nakama multiplayer dot players. And we'll just pass in that local ID. We'll make that equal to an object. And we'll just initialize our default parameters. So quote name is equal to local ID, comma, and then ready is equal to 1. And again, if you have your own game with your own stats, you can actually initialize that here, and that will allow you to handle that. And then we can basically just go keys is equal to bracket bracket local ID, and that just adds our player. And that's just so that we can actually play our game locally without having anything else. So that way, when you're testing your game and stuff, you don't have to go through and do the whole multiplayer thing. Now, what we should do is we should also verify our dictionary. So for player ID in keys, let's just verify that our players exist. So I'll just do this. So now we're going to sort our keys, and then for I in keys, this is where things is really going to start changing. So I'm going to pull this bit of code out. I'm going to control X that so I have it, and I'll say spawn player like that. And I'll pass in I, comma, and then an index value. And then we'll say index plus equals 1 like that. Now, I'm going to need to add in the ability to spawn a player. So we'll come down here and say func spawn player. And we'll pass in an ID, comma, spawn index. We'll make that equal to -1 like that. And now we can paste that in. Though we're probably not going to need most of this, but I'm going to paste this in so we have it. And then we'll probably end up deleting most of it anyway. But we'll keep our instance player right here where we instantiate our player. We're going to come in here and say instance player is equal to, instead of Nakama player ID is name, we're going to go strid like that. And then we will go ahead and add our child as expected. And then we should probably handle what happens if we pass in a -1. So sometimes you might want to boot the game up, like I said before, in testing. Well, we don't know the spawn index that we're going to drop them in, so we can just give them a random one, right? And also, what happens if we're out of range? So what happens if we're past that range of spawn indexes? So we just want to handle that use case here. So we'll say if spawn index is equal to -1, then go ahead and spawn index is equal to rand I modulus spawn points dot size. Like that. And also we can say or spawn index is greater than spawn points dot size. And that will allow us to handle that use case. So for instance, if you have 8 spawn points and 9 people join, it'll spawn somebody on top of the other spawn point. Or you could of course handle it so that it returns and just doesn't do that. Or what we could do if we wanted to, actually, now that I'm thinking about it, is we could get rid of this and say spawn index is equal to spawn index modulus spawn points dot size like that. And that basically would allow us to handle the same use case, but it would wrap it around. So think of it kind of like this. If I have 1, 2, 3, and then somebody joins and they're 4, what it would do is it would automatically wrap it around to 1. So they would spawn on 1 again. And I think that might be a better route to go because it's going to make things a little simpler than doing it the other way. But that being said, whichever one you guys prefer is a perfect choice. And now we need to set up our instanced player, which is right here. Dot global position is equal to our new spawn index. Like that. And then don't worry about this. That can go away. We don't need to worry about our index. That's being handled up here. And then we can basically return our instance player. And that can be useful if you want to spawn a player and then have its data. But in our case, it's not super useful, but I just wanted it to be there just in case we need it later in life. And now we need to basically handle our multiplayer signals. So when a player joins or leaves, we need to handle those broadcasted signals. So we'll say var multiplayer is equal to get tree dot get multiplayer, like that. And then we can do multiplayer dot peer connected dot connect, and we'll pass in on player joined mid game, like that. And then I'll duplicate this and we'll say on peer disconnected, like that. And then we'll say on peer left mid game. And basically, whenever a player joins or leaves and the multiplayer picks it up, that's how we know. That's how we're going to handle our stuff. And then we're also going to broadcast to make sure all of our players are synchronized. We'll say if multiplayer dot is server, then we'll broadcast out our locations. So I'm going to wait, and I'm going to wait about 0.5 seconds. It's going to give everybody some time to just kind of chill and synchronize up. So get underscore tree dot create timer 0.5 comma or dot timeout, and then I will say broadcast all positions, like that. And you'll notice that we're missing a bunch of functions. Don't worry, we're going to make all those functions right now. I just wanted to make sure that we had everything set up for this function, so we're good to go. So first things first, what is broadcasting all positions? Like, what is it going to do? Well, basically what it's going to do is it's going to tell everybody where their positions are. So we'll say func broadcast. Actually, I could just basically copy this, paste, broadcast all positions, and we'll say for ID in Nakama multiplayer dot players. We could say if has underscore node, and then we can pass str ID, like this. Then we could say var player is equal to get node str ID, and that'll pull back that specific player, and then we'll synchronize that player's position. So sync .rpc player .global underscore position, like that. And you'll notice that we don't have a sync player position. Don't worry, again, we'll be creating that in about 2 seconds. But basically what this does is when the server starts, it's going to tell everybody where to go. It's going to say, here's where you go, more or less. And that's how it's going to broadcast all of the player information that you might need that is node related. So position, rotation, things like that. It might also be useful for giving it sprites, things like that it might need. So that's kind of what this little function is for. So syncing player positions is pretty simple. We'll go at RPC, any peer, comma, call local. Whoops, quote, call local, like that. And we'll go func sync player position, and we'll pass in ID, comma, and position. And again, you can synchronize position, rotation, you can synchronize whatever you guys want, but in my case, I am just doing position in this case. So just keep that in mind. So now we'll say if has node str ID, like that, then we can go get node str ID dot global position, and we'll make that equal to position, like so. Else, if the player doesn't exist, we need to create it, right? So if for some reason we got into this weird situation where the player doesn't exist, we need to actually handle all of that, right? You can't synchronize a player position that doesn't exist, right? So we can come in here and say if Nakama multiplayer dot players dot has ID, then we can come in here and say var spawn index, and you'll notice, and then we can spawn it, and you'll notice that that's very similar to what we have here. And you'd be correct. So we'll come in here and we'll say, if we have it, we'll go ahead and spawn our player. So we'll just say var player is equal to spawn player ID, comma, and then we have to pass in a spawn index. Now, if we don't pass in anything, it's just going to randomize our spawn index. So it's up to you guys on how you guys want to handle that. In my case, I'll come up here and I'll just handle some wraparound logic on my own. So just if spawn index. And so I'll just handle that myself. So var spawn index, not var is equal to Nakama multiplayer dot players dot keys dot find, and then we'll find our ID like so. And this is basically going to return the key of that player. And so if spawn index is equal to -1, then we'll just make it equal to 0. And that will basically just spawn it in the correct position. And now we can basically spawn our players. So players equal to spawn ID, spawn index. And then we can set their global position. So player dot global position is equal to position, like so. And that'll basically synchronize our player positions when a player spawns in, if that makes sense. So basically, to recap, when a player joins, we need to synchronize their position and data, which is what this section does. We also need to come in and broadcast their positions. When a player joins, we need to broadcast their positions. So we're broadcasting their positions by basically looping through all the players that we know of. And we're saying, hey, if you have a node, spawn that player, right? Sync their position. And then basically we're coming in here and saying, okay, let's synchronize that position. So assuming that they have the node and that it exists, we're going to go and actually throw that player and synchronize their position. If not, then we're going to try to spawn them, more or less is how it's going to work. And now, what happens if a player joins mid-game? Well, that's what we have our func on player join mid-game. And we'll pass in an ID there. Now, when a player joins mid-game, first things first, we could probably print out that a player joined. So print player joined game, comma ID, like so. And we'll basically handle that. So the question is, what all do we need to handle? So when you do this, right, you need to make sure that everybody, all existing players know that the new player exists, right? We need to tell them that. And then we also need to spawn the player for everybody else as well. So we'll come in here and say if get tree dot multiplayer dot is server, then the server's job is to say, hey, here is the canonical data, right? Here is where everybody is. Because you don't want some random person to say, this is where my position is. Because if they're a hacker, they could come in and just say, I'm through the floor, right? I have 1,000,000 health and I'm somewhere you can't be, right? We want to make it so that the server handles all of that. So we'll come in and say for ID in Nakama multiplayer dot players colon if ID does not equal IC. So we can't do ID. My brain was just thinking ID, but what we could do instead is player ID. If player ID does not equal ID and has node str player ID, then we know that that's an existing player, right? So that player already exists. So if the ID is not equal to my current ID, so the person that joined, I guess let me take a step back and explain. So when a player joins, this is going to fire, okay? And it's going to fire with their ID. So if you join my game, you will show up as this ID. Your unique identifier will show up on my game as the ID that joined. So that's what this variable here is. This is the people that have already joined the game. So my ID and let's say my friends that are playing as well. So what happens is if the people that currently are in the game are not the player and that we, the server, understand, so I know that that ID is an actual person if I have that node currently in game. And the reason why that exists is because let's say somebody somehow joined the game without me knowing. They could exist and appear on your screen, and we don't want that capability, so that's what that's for. That little double check right there just checks for that. And when the player joins, we can say var existing player is equal to get node str player ID, like that. And then we can sync their positions. So sync player positions dot RPC ID, and we'll pass in the ID, comma, we need to pass in any additional things. So player ID, comma, and then existing player dot global underscore position. Now you might be wondering what this portion is for. So the way that this works is when you do RPC ID, the first parameter is the ID of the player you are communicating with. And then player ID is this ID here. So everything after this is the parameters that you're passing in. So for instance, if you wanted to pass in, like I said before, player sprite information, you could actually pull that data from their player store and pass it in here and then call it here. This is going to be called locally on the other person's side. So think of it kind of like this. The server is telling the player that they need to spawn a player and synchronize their position with locally on their machine. So I know that that's kind of confusing, but that's basically what it's doing. Is it's saying, I'm telling you that this player exists and you need to synchronize its position and it's located over here. So if, for instance, you needed me to change the sprite's color or something like that, you could pass that in here and say, here's their color. And when you synchronize their position, also here's their color. And that can help with setting up your players and things like that. So that's what that specifically is for. I just want to make sure I hammer that home just because it's a very crucial concept to how multiplayer exists inside of Godot. And once we have this will synchronize all of our players. So it synchronizes everybody that the player needs to know. So if you're joining my game, I tell you, here's all of the players' informations and what they need to know and everything, right? And then you need to also pass your information to me so I can synchronize everybody. So that's what this next section is for. So we'll say if not has node strid, then we can actually spawn that. So var index is equal to Nakama multiplayer dot players dot keys dot find ID. And that basically is going to pull back the Nakama player that has that ID. So that way we can validate that they're actually a part of our project, right? Because if they're not in here, then they have no point in being in our game and they can't do anything. So it's going to exclude them from joining our game because something went weird somewhere. So that's just a way to exclude that and handle that. And then we could say if index is equal to -1, then we can go in here and say index is equal to rand I modulus spawn point dot size, like that. Then we can say var player is equal to spawn player and then ID comma index, like that. And then we can say sync player position. We could pass in dot RPC ID comma player dot global underscore position, like that. And basically what this is doing is it's saying, hey, I'll put a comment in here so you guys know, sync joining player, or sync all players with joining player, and then this will sync joining player with all players. And that's basically what this does, is when a player joins, they receive all of the information from all the players, and then they then get spawned into the world. So it makes sure that everybody's synchronized before we start playing this game, if that makes sense. And that's basically all we need to do when a player joins a game. So now the question is, okay, what happens when a player leaves mid-game? Well, thankfully, leaving is really easy. Bunk on player, I believe we have on player left game. Let me see. Right here, on player left mid-game. So func on player left mid-game. And we can pass in an ID. So this gets fired off when a player leaves the game, right? And when a player leaves the game and we've done all the things, we can basically just say print player has left mid-game. comma ID, and then we can come in here and just remove them. So if has node ID, strid, then we can get node strid dot queueFree, and that will delete that node. And that's all we need to do, because everyone else will receive this when anybody leaves. So we don't need any kind of fancy weirdness. It just gets handled. And that's pretty much all we need to do in the scene manager. And I know that that was a lot, but it's a lot to change, right? We went through and actually said, hey, on ready, let's make sure everybody spawns correctly and hook up our proper connections here. And then we said, hey, how do we synchronize our players, right? So here's how we synchronize our players. Here's how we spawn a player, right? Much like we did before, but slightly different. And then we said, here's how we handle when a player joins mid-game. We synchronize their information, we synchronize our information, and then we're good to go. And then what happens when a player leaves mid-game? Well, we delete that node and we make sure it doesn't synchronize anymore. And that's pretty much all you need to know, at least when it comes to the scene manager. So now the question is, what else is left? Well, not a whole lot, mostly just the client. So let's take a look at our client.gd and let's actually get this coded and set up. So now we need to update our player.gd, right? So we're going to need to make some changes to that. So let's take a look at it. So inside of here, we're going to make a few small changes. First things first, we need to add in a ready. So func ready. And what we'll do is we'll say if name is equal to str multiplayer dot get unique ID. And what we'll do is we'll basically make it look slightly different. And that's just for us for stylized stuff. But I want to make it so that we actually have some kind of difference here. So modulate is equal to color 0.8 comma 1 comma 0.8. It's going to give us a slightly different color, and that's just going to give us a visual representation of who our player is. Now, of course, you don't have to do this, but I like to do it because I feel like it will be helpful. One other major change that we're going to make is when we sync our position, let's only synchronize it if it's changed enough. So I'm going to say if velocity dot length is greater than 0.5, then do this. And the reason why is because if a player is just sitting there, you really don't need to synchronize that data, right? Nobody's moved. So it's not really worth sending the packet across. And it's something that I just completely neglected in my previous tutorials. And that's pretty much all we need to do here to get our stuff to work. So let's head over to our game manager scene. So you can see here's our game manager scene, and let's actually see if this works. So first things first, I'm going to come in and do a debug, customize, run instances. I'm going to make sure I have at least 2 instances, and let's see if this works. Because if not, then we're going to have a lot of debugging to deal with. So let's hit the play button and let's see what happens. First, we're going to join, and then we are going to join with test2. We're going to say test, join, and then start the game. So you can see here's our player. We're running around, acting normal. And then we'll join test as well. Join, and there they are. You can see they can move and synchronize their data. You'll notice that they're not synchronizing unless we're moving left and right, which will be a huge data savings for us. And if this player quits, they get dropped off and it works. See that? And then I probably should have done 3 windows. So let's do this. Let's kill it. Go in here, customize run instances. Let's do 4 of them, and then let's run it. And let's see what we can do here. Now, there's only a few spawn points, so this will be an interesting test here. So first things first, test 2 right here. And we'll say test as well. We're going to join create, start game. Well, I guess he must not have joined. Join, so there we go. We'll move him over. We'll move him over. We'll come in here. We'll do test 3, submit, test, join. And something got a little funky here, so that's not a good thing, but we can take a look at that in a minute. What happens if this guy drops off? He does get deleted, so at least there's that. And if test 4 now joins. It looks like we got some broken stuff here. All right, so I think I might have figured it out. So the first thing I noticed was that the scene was getting duplicated when a player would be joined. When a player joined, and it was only when a third, fourth, fifth player would join. And the reason why is because since everything is kind of a mesh network, what's going on is the player is sending the server and the players are all sending their state and forcing the person who's joining to create a duplicate scene. And what I mean by that is if I hit play and I do test T join start, and then I grab my next guy, test 2 submit join, and then I do my third guy here, so 3 T join, you'll notice that I have a bunch of duplicate nodes, right? I have a bunch of duplicate characters. And if we take a look at our remote here and we go into our debugger and we check out, it looks like session 2 is going to be our session. You can see here it has 2 sets of the same node. So that's our first major problem that we have to solve. So basically what I think we need to do is if we take a look at on peer connected, so let's see right here, you'll see that there is a section here where we're saying get nodes in group in game dot size is greater than 0. So basically if the game's already been started, right, then go ahead and notify a progress. And that actually gets fired off because in our scene manager, we add it to a group called in-game. And that's how we know, right, if the game is already in progress. So I'm going to add in an and multiplayer dot is server. And that way it only fires off when the server is doing its thing. And that should solve our problem. So if we hit play, we hit test, T join, start game, test 2, password, join, T, yep. And then last one. So 3, submit, T, join. You'll see that now we have a at least somewhat working product. So you can see here, we can jump around. We can grab this guy, jump around, and we can grab this guy and move around as well and jump. But you'll notice that we have a duplicate node here. So what's going on with that? So basically, what's going on with this is that when somebody joins a game, they may have a host already, right? They may already have a node 0, if that makes sense. So if you come into, let's see, there's a section in here when we're spawning our stuff in the scene manager here, where we're spawning our players. So right here, if we put a breakpoint here and we go into our game here and we hit 4, submit, T, join, you'll see that we have an array of 5 keys here. So if I pull this guy up, you can see we have a number, a 0, a number, a 1. This 1 here is our player, our host. 0 doesn't exist. 0 has no reason to exist. It's something to do with how a player joins might create 0. And so the best way that I've found to handle it is to actually delete out that 0, or at least ignore that it exists. And so what I'm going to do is I'll come into my client.gd and we're going to basically not pay attention to a 0. So in our peer connected section here, where we have our second portion right here, where we're adding our players, we can just come in here and say var ID, local ID is equal to multiplayer dot get unique ID. And then we can basically just pass this to local ID. And we can say local ID is greater than 0. And that way, this does not get added to our player's dictionary if it doesn't exist, more or less. So if a player 0 shows up for some reason, we're just going to ignore that it exists. And then we'll do the exact same thing in our ready. So func ready right here. we will also do it in our on match join as well. So we're going to double, triple check that just to make sure that we don't have any issues here. So when somebody joins a match here, we're just going to check if not player has unique ID is greater than 0 and that. And that'll just check that, clean that up so we don't have to deal with it, and we'll be good to go there. And that should pretty much do it for our client. Let's go into our scene manager and do a double check as well. So inside of here, where we do our spawn code, right here, we pull back our local ID. I'm just going to make sure that our local ID is not 0. So if local ID is greater than 0 and not Nakama multiplayer dot players dot has local ID, then go ahead and do this bit of code here. And basically the reason why I'm approaching it this way is because it's allowing me to basically work against that little quirk that we're dealing with Godot. And so now I'm also going to do a double check here. So if local ID is greater than 0, else pass in a bracket. Just in case, again, another fail safe, just so we make sure that we're not dealing with that. And now, in theory, this should just work. So if we hit play, we can come in here, test T join start game, test 2 submit T join game, test 3 submit T join game, and you'll notice that we don't have that duplicate. And then finally, test 4 submit T join game, and you'll see there we go. And the best part is if somebody leaves, they get dropped out of the game. If somebody leaves, they get dropped out of the game. And that's basically how you do drop in, drop out multiplayer using Nakama with Godot. So if you like this video, go ahead and hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button, because I am here to make content for you guys. This video was a viewer suggested video. And if you have any suggestions, please leave them in the comments below, or jump on my GitHub. Link is in the description for that. And I'll be more than happy to take a look at it. Somebody recently suggested Postgre and going over Postgre and how to integrate it with Godot. Turns out that the plugin actually doesn't work anymore, so I developed my own plugin. I always love weird challenges, so it was fun to come through and build something like this for the community. So please let me know if you guys have any cool suggestions. And hey, if you have any questions or comments, please leave them in the comments below, or jump on my Discord. Links in the description for that. And anybody there will be more than happy to help you out. But that is all I have for you guys today. So thank you so much again for watching, and I'll see you all next time. Thanks.